Good day everyone. Today we'll discuss pressure at a point. It is a fundamental concept in fluid mechanics that explains how fluids exert forces and how pressure changes with depth. First things first, what is pressure? I think we're all familiar about what pressure is since we've already encountered this many times in our previous subjects, no? So pressure is the amount of force applied per unit area, and we calculate it using the formula pressure equals force divided by the area, and it is measured in pascals. And one important thing to remember is that if ang same force daw is applied to a smaller area, of course the pressure becomes higher because the force is more concentrated. Pero sa may mga examples ani niya, we actually encounter pressure in many everyday situations, like for example, tire pressure that keeps our vehicles running safely, underwater pressure that increases as we dive deeper in the ocean, or even blood pressure. It shows how strongly our blood pushes against the walls of our arteries. Now, understanding pressure, it actually helps us explain and predict this situation in real life. Now that we've already know what is pressure, let us define pressure at a point. Sumupod ni siya. Pressure at a point is how hard a fluid pushes on a tiny spot inside it. This push is the same in all direction. It's either up, down, or even sideways. Just imagine na lang na nakakas underwater, and then the water pushes on your hands, sa imong feet, and head equally. Mo nang pressure at a point. It's not just pushing down, but it pushes in every direction. And the deeper you go, of course, the stronger the push, because there's more water above you. This is how we understand pressure at a single spot inside a fluid. The concept of pressure at a point, as you can see in a fluid at rest, pressure is equal in all directions. And just like I have said kanina, pressure increases with depth, and the formula is pressure equals the density multiplied by the gravity multiplied by the height. This actually further discussed later. So pressure at a point is very important in engineering and science because it helps in designing hydraulic systems, dams, tanks, and submarines na gina-ensure nila that they can safely handle the forces nga gina-exert sa fluid. It also allows to predict how fluid push against surfaces and is essential for understanding the behaviors of fluid and equilibrium. Like for example, ang mga engineers they use pressure at a point to make sure structures like sa mga water tanks and underwater vehicles kay makawithstand safely sa pressure from the fluids around them. So that is actually the significance of pressure at a point.
When we talk about pressure in fluids, we don't just mean in the whole container. We're looking at a specific point inside the fluid. Pressure at the point is defined as the force acting per unit area around that tiny region. Mathematically, we write it as pressure is equal to force over an area. Imagine a small cube of fluid floating somewhere inside a liquid. The fluid surrounding it pushes equally on all sides. That means at that particular point, pressure acts in all directions and is the same no matter how we orient that small surface. This is actually a result of Pascal principles, which says that pressure applied at any point in a confined fluid is transmitted equally in all directions. So the key takeaway here is that pressure at the point is scalar. It has magnitude but no specific direction because it's the same in every direction at that point. Now, let's see how pressure at the point changes when the point is deeper in the fluid. From experiments and derivations, we find that the deeper you go, the greater the pressure. This happens because of the weight of the fluid above that point. Let's recall our basic formula. Pressure is equal to force over an area. In a fluid, the force comes from the weight of the fluid column above a certain depth. So, that weight is the force. Force can be get by multiplying mass times gravity. Now, mass can also be get by multiplying density times volume. Plugging that in, it will become density times volume times gravity. Now, volume can also be get by multiplying area times height. Now, plugging it all, it will become force is equal to density times area times height times gravity. Plugging that into our basic formula or our formula, which is pressure is equal to force over an area, we get pressure is equal to density times gravity times height. Now you're wondering, where is A? A was already cancelled out. This shows that pressure at the point increases with depth, and it depends on the density of the fluid, the acceleration due to gravity, and the depth of the point below the surface. So if 2 points are at the same depth in a fluid, they experience the same pressure no matter where they are horizontally. This is why underwater, your ears feel the same pressure from all sides at the same level.
Let's go move on to problem sets. We have the first problem set. A diver's suit has a circular viewing window with a diameter of 0.30 meters. When diving, the water exerts a total force of 1,500 newtons on the window. Find the pressure exerted by the water on the window. So we'll have to find the pressure in this particular problem situation. We got the force of 1,500 newtons and 0.30 meters for the diameter. Now, in this particular situation, the formula for pressure would be force over area, which is basic. Now, we don't have the value for area, but we have a clue what particular area are we going to be calculating, which is a circular viewing window. Circular being an area of a circle. So we need the diameter, which is basically this value right here, which is 0.30 meters. So what's the area? What's the formula for area of a circle? The formula of the area of a circle would be pi multiplied by the fraction of d over 2 squared. So this is the area of a circle formula. So using this formula, we can substitute the d with the 0.30 meters. So we have now pi multiplied by the fraction of 0.30 meters over 2 squared. So now, calculating this with your scientific calculator, you get the value of 0.0707 meters squared. So this is the area of your circular viewing window. Now we got the force and the area. So we can now calculate the pressure, which is 1,500 newtons over 0.0707 meters squared. So now, using your scientific calculator, you'll get the value of pressure, which is 2.12 times 10 to the 4th Pascal. Or if you want to keep things short, no, pressure would be equal to 21.2 kilopascals. So this is now your final answer to this particular question, which is the pressure exerted by the water on the window. Let's move on to the second problem set. A submarine's hull experiences pressure due to seawater. Find the pressure exerted by seawater at the depth of 250 meters. Find the gauge and the absolute pressure at that depth. Gauge pressure refers to the specific pressure being calculated, which is basically the seawater pressure at a particular depth of 250 meters. Absolute pressure refers to the consideration rather of atmospheric pressure. No, so solve for these two variables. So we have now the seawater density, which is 1030 kilogram per meter cube. So we got now all three variables needed to calculate the pressure here, which is basically density, gravity, and height. The density being 1030 kilograms per meter cube. The gravity being the usual 9.81 meters per second squared, and the height being 250 meters in this depth. No? So we got all three variables. We can now calculate the gauge pressure, which is basically the specific pressure exerted, which is in this case the seawater at a depth of 250 meters. So we can calculate immediately the pressure here. So we got 1030 kilograms per meter cube multiplied by 9.81 meters per second squared, which is basically the gravity, and then the height being 250 meters. All right. So using your calculator, you have the pressure gauge value of 2.52 times 10 to the 6 Pascal. So we have now pressure gauge. This is pressure gauge. No, this is gauge. To calculate the absolute pressure, we must first find the value of atmospheric pressure, which is basically a constant now of if I'm not mistaken 1.01213 rather wait, hold up. Okay. 0.13 times 10 to the fifth pascals. So that's the value of atmospheric pressure. To calculate the absolute pressure, so we can add the pressure gauge that we calculated earlier and add that with the atmospheric pressure. So using this formula now, we can immediately plug in the value of pressure gauge of 2.52 times 10 to the 6th Pascal plus the atmospheric pressure of 1.013 times 10 to the 5th Pascal. So you add that, you use your scientific calculator. Now we have the value of absolute pressure being 2.62 times 10 to the 6th Pascal. So now we got the value of both pressures. Now we have the gauge and the absolute pressure. So that's basically the idea of solving pressures in this particular situation. I hope you understood this discussion on pressure at a point. So I hope you understand and have a good day. May God bless you.